constantly said that the future of our country lies in the hands of our young people.
That's right. Well, this could not be truer for a collaborative group of seriously smart young people who, under the leadership of one of their peers, are challenging themselves to create something that we've only seen in sci-fi movies.
In the engineering department at Wits University, a team of master's students are working on a game-changing project, a low-cost robotic prosthetic hand.
The idea for the project came about when I was doing my master's in 2008. I was looking for an application of machine learning and artificial intelligence in the body, and then I came across the idea of being able to control a robotic prosthetic hand with neural signals from the muscle from the brain. And I found it extremely fascinating and something that would be challenging and would keep me busy for the length and duration of my career. So it was something that really sparked my interest and something I wanted to run with. So a low-cost solution, which would cost approximately 2,000 Rand, as opposed to 100,000 Rand, would benefit and impact a whole lot more amputees within the South African context. These people typically can't afford to buy a robotic prosthetic hand or a normal prosthetic hand, which would come from either Europe or America. So it would allow these people to be able to perform simple daily tasks such as holding a glass, writing with a pen, waving, opening a door. So their quality of life would be improved significantly, and they would have access to it because it's a lot cheaper than the other solutions that are offered commercially.
The team have advanced the project at a rapid rate thanks to 3D printing, which lowers the cost and drastically reduces the turnaround time of prototype designs. The aim is to use 3D printing for mass production, which creates a lighter and cost-effective product.
So what we're doing now is we're testing the hand's ability to perform a fist in holding a ball. I'll place the ball into the hand, and as he contracts his bicep, the hand proportionally closes. The hand is then measuring the forces that he's exerting onto the object, and we're actually feeding it back to him in this vibration cuff, which has little cell phone vibration motors to give sensory feedback in the same way that a real human can feel. And the computer, what it's actually showing is the actual forces that the hand is experiencing in real time, as well as the force of vibration that he's feeling on his hand in real time. Okay, so now we're placing a ball into the hand, and we can see that the palm, the index finger, and the middle finger are currently being activated, and that's feeding vibration back to him.
So currently the hand is actually using the bicep to form a grasp. Now a future improvement on that is that the bicep muscle is also used when the hand is performing other actions. So for example, pulling something towards you, or if you're putting a shirt on, like a long sleeve shirt, and you're grabbing onto that sleeve and then you're stretching your arm out. So what I'm trying to do is I'm trying to figure out when the hand wants to perform the grasp and when it wants to actually perform the reach, at which moments, because that muscle is being used for those two different actions. And I think this is such a good contribution to the prosthetic world currently, because we want people that have a limb loss to be able to feel as natural in using this hand, and possibly as this hand gets developed, a lower arm, as they can, because a limb loss, especially an upper limb loss, is a really great loss because your arm is used for so many daily activities.
The current focus of the project is improving the number of functions of the hand and making the movement more natural. Testing with amputees will likely only happen in 3 years, and then this group of young people could change lives here and abroad.